All right, so the question has to be asked. The night is young. Are we doing
Oh
day
no,
11?
are we gonna do another day?
All right, 3, 2, 1. Good luck. All right, what's up, chat? She can't hear us anymore, so we can make fun of her. She's lame. No, I'm just kidding. She's actually really awesome. I'm lying. Don't make fun of her. It's super cool. This is super fun. I love having someone else that like does bash and wants to challenge with it. That's super neat. All right, so we're making day 11. Cool. We're gonna head over to the web browser and we're gonna pull up day 11. And what do we have here? We have, yeah, RTFM. You better believe I'm gonna read this. Plutonian Pebbles. The ancient civilization of Pluto was known for its ability to manipulate space-time, and while the historians explore their infinite corridors, you've noticed a strange set of physics-defying stones. At first glance, they seem like normal stones. They're arranged in a perfectly straight line, and each stone has a number engraved on it. The strange part is that every time you blink, the stones change. Ooh. Sometimes the number engraved on the stone changes. Other times, a stone might split in two. Okay. Causing all other stones to shift over a bit to make room in their perfectly straight line. As you observe them for a while, you find that the stones have a consistent behavior. Every time you blink, the stones each simultaneously change according to the first applicable rule in the list. This is wild. Like, so they're like in some sort of like superposition type of thing. Cool. But we can predict how they're going to move. If the stone is engraved with the number 0, it is replaced by a stone engraved with the number 1. Okay. If the stone is engraved with a number that has an even number of digits, it is replaced by 2 stones. The left half of the digits are engraved on the new left stone, and the right half of the digits are engraved on the new right stone. The numbers don't keep extra leading zeros, i.e. 1000 would become stones 10 and 0. Okay. If none of the other rules apply, the stone is replaced by a new stone. The old stone's number is multiplied by 2024 is engraved on the new stone. Okay. No matter how the stones change, their order is preserved and they stay on their perfectly straight line. How will the stones evolve if you keep blinking at them? You take note of the number engraved on each stone in the line, your puzzle input. If you have an arrangement of 5 stones engraved with the number 0, 1, 10, 99, 999, if you blink once, the stones transform as follow. This is cool. This sounds like I can iterate through it step by step, so hopefully this will be easy to, if we get into an issue, we can figure out where exactly our issue is. Oh yeah, what's up, Justin? How you doing? This sounds heavy? Yeah, it's going to be a little bit heavy. And if you're just tuning in, I am racing this person. This is Bad Cop. She is very good at Bash, and she's streaming over on Twitch, and we're racing. We did day 10 earlier, and she wiped the floor with me. She destroyed me in that. So hopefully I got some redemption here. So here's the arrangement. The first stone 0 becomes a stone marked 1 because it's 0, so it becomes 1. The second stone 1 is multiplied by 2024 to become 2024. Cool. The third stone 10 is split right because it's an even number into 1 and 0. The fourth stone 99 is split into 2 stones marked 9, right. And then the fifth stone 999 is replaced by a stone marked 2, right, because 999 times 2024. This makes sense so far. So after blinking once, or iterating once, your 5 stones would become an arrangement of 7 stones engraved with the numbers 1, 2024, 1099. Okay. Here is a longer example, 125 and 17. This gets multiplied by 2024 because it is an odd number. This gets split into 1 and 7 because it's an even amount of digits. I shouldn't say even number, even amount of digits. Yeah. So this gets multiplied by 2024 and this gets split. After 2 blinks, this one isn't even, so it should be 25300, but they all get chopped off. Cool. This one gets multiplied by 2024 and this one gets multiplied by 2024. Okay. This all makes sense to me. I don't see anything here that's weirding me out. In this example, after blinking 6 times, you would have 22 stones. After blinking 25, you would have... Yeah, this is like some exponential type of growth here, which is crazy. Considering the arrangements of stones in front of you, how many stones will you have after blinking 25 times? Okay. Okay. Let's go ahead and get our puzzle input. What do we have here? We are in day 11. Let's vim the example. Input. You can't see my terminal, but don't worry, I'm just literally copying over example input. And then real input. I'm not going to share my terminal for this and my browser. I'm going to remember where I put it. Okay, get your puzzle input, go here, Oh, wow. The puzzle input's very small, but the numbers are very large. So that's going to be pretty gnarly. Cool. So now share back the terminal. So now if I cap my example, we should be able to go through this process. After blinking 25 times, you would have 5, 5, 3, 1, 2 stones. So when we blink 25 times and run it through this algorithm, we should have that many stones. Okay, let's go ahead and do a part 1. We're going to jump right into it. Always be afraid of small inputs. I am. The fact that the input was very small is what scared me. Like, I'm not even kidding. I looked at that and I was like, oh God. That means so much is just on the actual like algorithm. Because if I don't get the algorithm right, the answer is going to be way off. Like way off. So what we'll do here, while read -ra line. Oh wait, no, it's only one line of data. So we can just do this, read -ra line, and now we have an array of all of the inputs. So for stone in stones, do done, echo stone. This will loop over each one. So if we have the example input and we run part 1, we should get, them separated by new lines. Cool. Nothing weird there. We just have an array called stones, and each element is the number that's in there. So now what we have to do is run the algorithm once on this. So we'll just make a function. We'll call it step, and this will step the algorithm once, and then we will figure out what has to go in here. And then for our final loop, we'll do like a, we'll step it 25 times. But for here, we'll just step and like print. We'll just call it P. So I'll make a function called P that will print out our stones. No, I won't. I like my functions to have names that I'll remember later because I'm stupid and forget. Print stones. And when we print our stones, we'll just try to think of a nice way to print them. Just do this, honestly. Actually, wait. They're just numbers. What am I doing? Just join them by spaces. There we go. And we can make that more complicated. So we'll step it once, and then we'll print the stones. And it's bash. You have to have something in here. So we'll print stones, step once, print stones. Cool. So our step function didn't do anything. Now we need to figure out what our step function does. Our step function will loop through. We'll make a new array. This will be where all the new inputs will get held. And then we'll loop over the stones in here. For stone in stones. Do done. Local stone. We'll loop over each one. And then we'll do some if statements on this. If stone is equal to 0, then it becomes a 1. So we will push 1 into our new array, and we are done with that number. We need to check if there's an even number of things in stone. So if how do we do this? Let me think. If the length of the stone, so we're going to treat it like a string here of the digits. If the length of this, we need to check if it's even, modular divided by 2 equals 0. Then echo even digits found with stone. This is just debugging. Actually, you know what? I'm going to do what people told me to do. We're going to make a debug function. There we go. We made a debug function now. So even digits with stone. Then we'll do, I don't know, something to it. Do something. We have to split it. And then the final thing we do is we multiply it by 2024. And we push it back in. So new array plus equal stone times 2024. There we go. So now we just have to split this. So let's go ahead and get the length of it. Let's just write the logic. The length of the stone. Now we have the length. Middle is we will split the length in 2, and it's even, so we know this will work. And now we need to get the first and the second. So the first is whatever the stone is. Yeah, let's see. Yo, what's up, Seeknay? How you doing, man? Welcome to the stream. Also use the debug function. Yeah, I agree, I should. To get the first section of it, we're going to take the stone and we're going to substring it from 0 all the way to middle. And then to get the second part, we're going to substring it from middle onwards. And then we are going to push 2 elements into this array, first and second. And I think we're done. I think we're done. We just have to do stones equal new array. This just copies it over. Cool. Now let me go ahead and run this. And so now we have 255. Let's turn off debugging and let's do for I in 0 ... I don't know, 5 do done. Change this to 1. We're counting. We will step and print the stones, and then we'll print these stones up here. So we're going to do it 5 times, and now we run it. This is what our evolution looked like, and this is what it should look like. 103 ends in 32. This looks good. This looks absolutely good. So after blinking 6 times, okay. So after blinking 6 times was the example they gave us. We need to figure out how many stones we have. So we echo the length of stones. So after blinking 6 times, we will have 22 stones. According to this, we should have 22 stones. No way. No way. We have 79 after the real input. We're going to go over here. We're going to type in 79. We're going to hit enter. That's not the right answer. Okay. Darn. So close. So close. Wait, what did I put in? Hold on. Did I do something wrong? I did 1 to 6. Wait, I didn't. Yeah, right. I didn't change it. I didn't change it. We're close. We're close. We're close. 25, not 6. 25, not 6. Listen, aneurysm. You're right. You're right. It's seemingly not my strong suit. But what happens is I'm in a rush and I'm nervous. So cool. Now we have value 2 great for base. I understand what's happening there. We have array numbers that need to be chopped off. So leading zeros need to be returned or removed. So how do we remove leading zeros? What's a good way of doing that? Or can we just do this? Can you just do like this? Let me remember this syntax for how to do this. If I have a equals 08, I can do like a. Yep, and I get an error. I think you do 10 pound. Nope, that's not right. Pound 10. There is a syntax for this. There we go. 10 pound and then the number you're trying to do. This will treat it like a number in base 10. So we can just do this. All right. Let's just chop off the leading zeros. Have 768. That's not right. Cool. Let me think about this. Doing something wrong. What am I doing wrong here? This should remove... Okay, well that's just wrong. It's turning them all into zeros. I'm doing something very, very stupid here. First pound. Okay. So if we have 6 on the example input, then we have 8 at the end of it. That's wrong. Yeah, somehow I'm just like losing these numbers. What am I doing? Oh, that's what I'm doing. 22. Okay, that looks right. Now we change this to 25. 55312. I'm going to stop printing them because that is causing a lot of output. So we got the right answer there. Real input is that. We're not printing them, so we're not really going to get any feedback. 119753. Let's go. Let's go. Let's go. Hello there, friend. GG on part 1.
I think I'm so close.
Oh no, are you really?
Yeah, let me see.
Okay, I'm gonna pull up your stream.
I think I just need to count how many things are in my array, and then I'm there. Let's see.
Oh my god.
Let me turn that off.
Oh,
wait, what's still echoing? Oh.
Yeah, I had to
Why
turn
am I
off
getting
something.
2 prints? Yeah. Uh-oh. But it might be too slow. Okay, no, it's not too slow. All right.
I love your progress.
That's not the right answer.
Oh no. Oh,
All right.
no.
Well, you've got a head start.
This is it. This is my redemption arc. All right. Good luck on part 1. I'm going to tackle part 2.
Good luck.
I'm way too excited about it. I love winning, but I love competition in general. It's just so fun. Oh boy, you ready for part 2? We're going to destroy Bad Cop now. Part 2. The historians sure are taking a long time. To be fair, the infinite corridors are very large. How many stones would you have after blinking a total of 75 homes? What? You know how long that's going to take? You gotta be kidding me. That's the part 2? That's what part 2 is? I'm super afraid, dude. I'm super afraid, bro. Don't do this to me. Oh my god. Okay. Well, okay. Terminal. Sorry. Yeah, my bad. Thank you. I'll show you guys what I did. Literally just changed 1 from 75, and then I echoed I here, so at least we'll have some indication. I'm literally so afraid. You have no idea. Okay, we're good. How do we get that? Oh. It's this logic. No, that's not even right. Let me do some testing here. A equals 000501. Echo A, delete that. Do this, delete that, deletes them all. What am I looking for here? It's just this, right? But why does it leave the rest of the A's? What am I trying to do here? I'm trying to remove all the zeros from the front of the string. I don't see what I'm doing wrong here. How do you trim off zeros from a string? I'm blanking here. I swear this is right. I swear this is right. I mean, obviously it's not. What I can do is I can say start zeros. I don't know what I'm doing wrong. I need to figure this out or else... And I need to figure out a way to do this quick. I can do that. Will this break on an octal number? Yeah, it will. What am I looking for? Why? I'm blanking on this. I might be able to use that notation you were talking about. The word is expanded to produce a pattern just as the path and expansion matching is the pair matching the beginning of the value of the parameter, and the result of the expansion expanded the value of the parameter with the shortest matching pattern in case. I will probably use that notation, but what am I doing wrong here? That's just removing 1 0 from the beginning. I don't know what the hell I'm trying to do. I guess that's it. Yeah, I guess I just have to use that notation. Okay. Whew. We're good. We're good. We're just going to use that weird notation. And we're going to set it to 25 just to make sure that it works. What am I doing wrong? Oh my God, what am I, stupid? I see the $sign and I put it to the left of the $sign even though this is in the wrong spot. Nah, it still breaks. You said the $10 should be inside of it. It should. This should be it. Oh, I got rid of this. Yeah. Well, it would help if I had reading comprehension. Wow, that slows down like crazy when it gets there. 199.753. Okay, so that's right. What I'm going to do, now that we know it's right, we're going to write out the data. We're going to print the stones, and we're going to write it to data I.text, so we at least have a backup of it, so if I have to break it early, we can at least like write the data out so we know what's going on. And I'll explain what I mean by that. So this is going to run over here, and now if we go over into a different terminal, and we figure out where we are, we can go to day 11, we can ls data, cool, and we can see how far it is. What are we on, 25? Oh, I only made it go to 25. That's fine. And then, assuming we don't have to change any logic in the future, we're good. Otherwise, rip your SSD. Yeah, possibly. If the files get too big, maybe I won't do that. Yeah, 26 is a meg. Yeah.
All right, I got part one. I'm angry about it.
Wait, what'd you say? What'd you say?
I said I got part one.
Oh man, nice job. Nicely done.
How's part two? I see it's a very simple change.
Have you looked at part two?
I just clicked it. We just gotta increase the number to 75. What's the problem?
That's it. That's all we have to do. I
And
don't
then
have an
just
answer
run it
for you yet.
for an eternity.
Yeah, I don't have an answer for you yet.
Okay, okay.
I'm at 29 out of 75. So I mean,
Oh, you're just going for it.
I went for it, and then I realized I had some bugs in my original code, and I just had to clean up some stuff. And then I was like, oh, I'll write the data to the file system every step, so I have a backup of it. And one of the files is like multiple megs. So I was like, well, that's not going to work. This is not. I'll tell you right now. I'm at step 31. I don't think this is tenable here.
Yeah, I don't think this one's brute forceable.
Yeah. So
All right.
we're gonna have
Well,
to
it
come up
sounds
with
like
a
we're on
different
the same step then.
yes, we are. It took me a bit to get here, but now we are. I would say
I have
we're
a
even.
I have a quick question.
Okay.
So how did you strip the leading zeros? Because I was doing it wrong.
I was. I'll send you the part of my VOD. I struggled with that for about 10 minutes.
As soon as I
kept,
figured out it was the problem, I also struggled with it.
I kept using parameter expansion, and I could
Me
not
too.
figure out how to. Yeah, I had the man page open, and I was looking at the parameter expansion and everything, and I could not for the life of me figure it out. I don't know what's going on. I was doing like pound sign 0 star, pound sign 0, pound sign. Like I could
Well,
not.
because zero
get to work.
star, the star doesn't match the zero. It matches anything.
Yep, and I
Yeah.
found that out after. The way I did it was I used math expression. So you can do the number
Oh,
10,
that's smart.
pound sign, dollar sign your variable, and that will force it to be base 10, so it'll strip any leading zeros for you.
I just, used the hammer, the regex hammer.
I mean, hey, you got to do what you got to do. I was one step away from that.
Yeah. Yeah, I was like, why am I getting so many errors that, number is too big for base?
Yep. Yep. And I've dealt with that before, but yeah. So yeah, I used numeric expression to force it to be base 10, but I had to pull that syntax out of the woodworking. Oh my god.
All right. Well, I'm gonna go ahead with part two. I'll see you on the other side.
Same. I'm at step 34 out of 75, so I
Oh
think I
no.
got you beat.
I gotta start my brute force now.
Yeah, exactly. All right, good luck. Don't worry, aneurysm. I commented out that part. So these should not be growing. What did I call it? Data? Yeah, we're only at 7 megs. It's not going to grow anymore. I commented that part out. Once I saw that 1 megabyte file, I was like, nope. I know how this is growing. I know this is going to be untenable. Okay. Man. Oh, not disk RAM. Yeah, you're right. That is RAM. I don't know why I just assumed that'd be disk. And I even ran the du command. God, I don't want to know what my RAM looks like on here. I don't even want to know. Well, we're on Mac, so we don't have the free command. I think I have a thing that I use. So we're using 82 gigs out of my 128. So luckily I have a super beefy computer. I have a computer downstairs we could use. What operating system is this? This is OmniOS. I have to remember how to get the memory on every single operating system. So we do have 256 gigs of RAM on this computer, so we could get one more evolution out of it. Yeah, what's up, Signe? Yeah. I closed it. There are no rules to that. You can use whatever you want. The goal is they give you input, they give you a puzzle, and you have to give them output. That's it. Use whatever you want. Yeah, just a few hundred petabytes. I should be good. Yeah, I'll be good. I'm gonna quit this. We're done brute forcing it. That is clearly not the answer, but the way the puzzle's constructed, it makes it seem like it's the answer. So I respect the heck out of it. We need to come up with a way of doing this algorithm differently than how it's described to us, because this algorithm is laid out for us, which means that we need to think about this differently and come up with like a different solution for this. So we need to come up with some sort of rules, like if you multiply a number by 2024, does something always happen? Can we like assume what the next output's going to be? Maybe we have to do 2 steps ahead. I don't know what it's going to look like, but we're going to have to think about this. So when it's 0 becomes 1, that's super easy. When it's evenly splittable, we split it. Cool. I played blackjack before. I know how to do that. Always split. It's always in your favor. And then when it's not evenly splittable, we multiply it by 2024, and the size of it grows like crazy. Let me think about this. I have to think about multiplying a number by 2024. Is there any magical property that happens when you do that? Like, will it always result in even digits? Probably not. That doesn't really make sense, but maybe there's some logic to that. Because that's sort of our biggest thing. Once we start multiplying by that, we get really large numbers. Really large numbers aren't the problem. I think maybe just holding it all in memory is the problem. Wait, am I dumb? Instead of trying to hold everything in one array, do we just... None of the numbers play off each other. We can just evolve each number separately. Let me think about this. When we do an iteration step, we'll go from 5 numbers to 8 numbers or whatever. We can process those 8 numbers separately. We literally can just evolve a single number until the end. And then that can go and evolve a single number to the end. It's going to get big, and I'm trying to think of how to... The problem with this is just how to be efficient with RAM. So let me think about this. If we just have 125, we can evolve it into this, and then we evolve that into this, and then we just have 2 more things. Yeah, the problem is just how do we store this data, because it's just a lot of data, right? Is there a secret to this? Because all we need to know is how many stones there are. I'm wondering if that's a hint. Again, if you guys know the answers, please don't tell me. I'm not trying to cheat. No one is doing that. I'm not trying to cheat. I'm actually just trying to problem solve this. I wonder if there's a secret. Like a 0 will always become a 1. And then a 1 will always become a 2024. Like it's guaranteed. And then yeah, hold on. We're on to something. And then a 2024 will always become a 20 and a 24. Hold on. We're on to something. Vim notes.text. Didn't even think about this that way. A 0 always becomes a 1, which always becomes a 2024, which always becomes a 20 and 24, which always becomes a 2, a 0, a 2, a 4, which becomes... This 0 goes through the process that we already know. We already know the evolution change for the 0. You're right. I'm not sharing the terminal. My bad. Here's what I'm doing. Literally just making notes. That's all I'm doing. We're making a Christmas tree. How nice. So once this 0 gets generated, well, we know how that evolved. We're making the evolution chain of that. When we get to a 2, we multiply it by 2024, which becomes 4048. 4048. And... what's the other one? 9096? 8096. Yeah, and then once we're down here, we have 40 and 48. We don't care about that. We've already figured out that one. 40, 48, and 80 and 96. So now we have 4048, 4048, 8096. We just need to figure out the pattern of all these. We just need to evolve a 0 enough times and throw out when it becomes a 0 to figure out the amount of iterations it does. And then we'll get some information out of it. I don't know. I'll be honest. I don't know where I'm going with this. But we're figuring it out. So we have a 4. Well, we know how the 4 is working because we haven't figured out the 4 yet. The 4 became the 8096, which became an 80 and a 96. So we have to figure out what an 8 and a 6 will do. So I'm doing it in a different window. You can't see it, but 8 times 2024, 16192. And a 6 times 2024 is a 12144. You can always count manually 75. I can. I absolutely could. That is definitely an option. These are not evenly divisible, so they just get multiplied again. These are big numbers, but it's not a problem that they're big numbers. Like, that's not a problem. Yeah, because eventually we'll hit an even number. I don't know if this will... Okay, that does copy the result. Perfect. And then 12144 times 2024 is that. This is great because now we have even numbers, so they get split again. They get split into, well, they become this, and then they split into this, and then they split into this. Oh my god, yeah, wait a minute. We just have to evolve every... Yeah, we just have to evolve every number 0 through 9. Wheels are churning. We just have to evolve every number 0 through 9 and then have a hash of all the results they go through and then figure out through that what that number would become. Well, no, 0 through 9 doesn't work because we have to multiply bigger numbers. Hold on, we're getting there. We're circling the drain here. The answer's going to reveal itself. Okay. Oh wait, hold on. I got like a notification or something. What is that? Okay, I think we're fine. Okay. Okay, cool. We're good. Okay, yeah, I think we're onto something. So now all we have is single digits that just need to run through this algorithm. So like we have an 8 here, but we already know what an 8 looks like. The only problem is when we have a very, very large number, like the test input, you have to evolve until you get to something we know how to do. Because like the test inputs will be big. We have to break them all into single numbers. We're going to try and do this. We're going to CP part 2 to a program called evolve. Evolve will take a single number and we will evolve it. Yep, we will take a single number and we will evolve it. Oh my god, yeah, because we don't even care what the numbers are. We just care how many there are. Oh my god, this is like... I have to go congratulate. I don't know if Eric... I think Eric makes all the puzzles. I have to give him props for this one. This one seems super fun. Oh my god. Okay. Stone equals $1. Yeah, so what this does, this will just evolve a single number. I'm thinking ahead right now. That's what's happening. I should have just left these in here. I like to work in functions anyways. Why didn't I think of this? Cool. Okay. For the number we want to evolve and how many times we want to evolve it. For I equals 0, I less than iters I plus plus, do. Step, print the stones, done. Okay, so if I wrote this right, we can evolve the number 1 5 times and we'll get nothing. That's really cool. What did I do wrong? Help if I made an array here. Actually, it shouldn't be necessary. Yes, it should. Cool. Yep, there's my problem. Close. I'm basically just rewriting everything. Okay, so this is what it looks like when we evolve a 1 5 times. Let's go ahead and just actually print the input at the beginning. So we'll have 6 things because it'll show the initial one. So this is what I was doing by hand. Let's evolve it 10 times. Yeah. You know what we need? There's a word for this. Memoization. That's what we need here. We need a function that can evolve a single number and also builds a hash of all the results of all the numbers. So we will slowly go through and memoize every single one. I think that's what we need. I've encountered this in the past. That's the only reason I know how to do this is I've encountered this when working on performance at a computer company a decade ago. Cache. We'll make a cache. And then local cached equals cache at that number. And then if dash n cached, we'll have to come up with the formula because we can't do nested arrays in bash, so we'll have to do like just an array. So actually, I'll just separate them by spaces. This is super easy. I'm just gonna cheat. I'm writing sloppy code. We're just gonna put cache in there, but we're not gonna quote it, so it will get expanded, and we'll just separate them by spaces. If it's cached, then we return the cache and we continue. Super duper simple. If it's not cached, then we calculate what it is. Why is there a continue here? We calculate what it is. Make a result when we get down here. What do we call it? New array. New array plus equal the result. And then we will memoize the stone to set equal to whatever the result is. We need a string of the result. So we can do this. Bad code. I would never encourage people to write code like this, but it's going to work. It'll separate them based on spaces. So now we've built a cache. Syntax error. We've almost built a cache. Oh. Still feels really slow, doesn't it? What is it doing? Oh my god. It's doing a lot. Let me think. What are you caching? Let me, hold on, let me work through this. When we have a stone, we know how to evolve it. We evolve it into multiple different things, and then we cache that. I'm assuming some loop is gonna reveal itself to me. But I just have to think. I have to think. Because there are ways we can make this easier. Because at the end, we don't care the stones. We just care how many there are. So if we have the number 0, when do we get into a loop? And whenever we get into a loop, we can know like, oh, a loop happens after 17 iterations, and on iteration 17, we should end up with 18 stones. Yeah, so we should basically have like a list of things. It'd be like a list of lookup tables where it's like, oh, you had this number. After this many evolutions, here's how many you would create. Yeah, because this is still painfully slow. It's faster, but it's still slow. It's probably way too much to cache if I had to guess, assuming my cache is implemented correctly. Which it's not. I'm going to do this against the example input. Yeah, we're just going to see. So none of this stuff is cached. None of this stuff is hitting. Yeah, none of these have cached results. Are they? They're not all unique numbers. I think my logic's bad here. I don't even know if this is still viable. I just want to fix the caching logic, because then, yeah, that'll do it. It's still growing. Like, it's growing very large, and it's slowing down. Still using 80 megs. We're climbing up. We're climbing up there in memory. I had 33. Yeah, so this isn't gonna work. Now we have to figure out number of stones. Here's what I'm seeing. I don't want any hints, but here's what I'm seeing. Eventually, we will be able to get every number back to 0. I think that'll happen. I don't know how big those loops could be, but I think everything will tend towards 0. Once you get to 0, we're back at the beginning of the process. Oh, sorry. Yeah. If you want to like throw out like fun ideas or whatever, or like if you see obvious things, that's fine. But I don't want someone to like help me solve this. That's not my goal here. Listen. I owe you a kickflip. I so owe you a kickflip. And I don't even care if you're like, oh, I'm joking. It's fine. No, I'm committed. It's going to happen. 2025 is the year of the kickflip. Okay, so this memoization is a good idea, but I wonder if there's just too many things. I do I need to write an algorithm to do this? We have an evolve algorithm where we can take a number and evolve it X number of times. We need to figure out like when a loop emerges. Like if we evolve 5 one time, 10 times, boy. Yeah, like I think we just need to figure out like, we're just seeing repeats here. The nice thing is, yeah, once an even number, even digits, whatever, emerges, it will always work its way down to single digit numbers. It has to. So once you have something, no, it won't. I'm lying. Yeah, because if it was 6 and then you divide it into 3, yeah, then it totally won't work. Let me see. Listen, man, I'll try my best to solve it, but go to sleep if you need to. Oh my god, this one's cool. I really really like this puzzle. I don't know what the solution is going to be yet, but I really really like it. This one's grinding my brain in a way that no other puzzle has quite yet, and I really appreciate that because I'm not up against my poor coding skills. I'm just up against actually planning out an algorithm. And I also know Bad Cop can jump in at any moment and be like, "Hey, I got it," and I'll be like, "I hate you." Not really. Is there anything special about 2024? I know it's the year, but like, is there anything else that can be gleaned from that? I could write a simple algorithm. I could write a simple algorithm that starts filtering things out. Like, once we encounter 0 again, we filter it out. Like, how many steps does it take to get from a 2 to a 0? No, because then you go back to a 4. How many steps does it take to get to all single digit numbers? I don't know. I gotta think about this more. How long until every number hits a 0? I'm gonna try that, but I don't know if that's gonna work. Um, Kind of just throwing things at the wall now. Let me think about this. Um, okay, so we're starting to filter out the zeros. There's still so many pathways. Do I memorize the first X evolution chains? Do I just memorize the first 100 evolution chains until 0? How long does it take to like a 6 to get to 0? I don't know. Well, wait. A 6 becomes a 1, 2, 1, 4, 4. Becomes this. Becomes this. Becomes this. And gets stuck in a loop. A 6 generates a loop. Okay, I'm beginning to see. I'm beginning to see. I'm beginning to see. If you have a 6, the next time you evolve it, hold on. Let's use 6 as an example. If you have a 6, the next time you evolve it, you will get this 6 again. 1, 2, 3, 4, 5. On the 5th iteration, you will get the 6 plus these more stones. But then each one of these stones has its own set of patterns that they follow. But the 6 will always follow this same pattern. And you'll end up with a 6 at the end here. Yeah, okay. Let's just try this. We're going to look at some numbers. When you have the number 6, 1, 1, 2, 4, 8, 8, 11, 19, 29, 46. I don't immediately see a pattern through those. There might be some sort of pattern. Right, I'm filtering out zeros. Let's not do that. One, 2, 4, 4, 7, 14, 16, 20, 39, 62, 81. Yeah, I don't immediately recognize like what this pattern is. It's not like anything that just emerged, but like I do not know. I really have to think about this. I really cannot get my brain to think about it. I wonder if representing the numbers in a different base might help. Because like if I were to represent it in binary, no. No, it doesn't work. I have to think about a way to figure out if there's an even number of digits, but I don't think binary is gonna I don't know if that's gonna help. Let me think. Every time we blink, it grows exponentially. Yep. So every time we blink, the algorithm happens to this, and the stones multiply and they become newer numbers. But I don't know how many times they're going to multiply. There's so many different arrangement of numbers. I could memorize. Let me think. I could memorize the amount of stones that get produced. Like, if you have a number, is it going to split stones? That doesn't really help me. Because the way the stones grow is if they split or not. That's all I really need to calculate. if they split or not. There's so many different numbers, but like what they split into is important. Because then I have a new number to work with, so I still have to memorize them. I still have to like run a calculation on them. Like the number 512 becomes this large number, and then that becomes this large number. Like we're not even like, so much that has to happen. What do you think? Yeah, because every evolution, if we have 5 stones, the next evolution will have 5 or 10 stones. It'll be between 5 and 10. We know that every iteration at most could double and at least could do nothing. Let's see. Yeah. Anything else I say is too much of a hint? Yeah, I don't want any hints. I mean, I appreciate you trying to talk me through it, but like, yeah, definitely don't want hints. If a loop happens in a low number of blinks, you can calculate in which point you'll be at 75, right? Other times the stone might split into 2, causing all other stones to shift over a bit to make room. So for a while, every time you blink, the stone simultaneously change according to the first applicable rule. No matter how the stones change, their order is preserved, and they taste. Yeah, right. So like, I don't. Yeah. You know what's funny? If I did go rust, there might be a chance I could do it, but like, I still think this is one of those problems that just the amount of storage space I need for this is kind of just crazy. I have to come up with something more efficient than this algorithm. The problem is tricking you. It's a puzzle. Rust won't help without the right implementation. That's what I think. Yeah, that's what my mind, especially talking to Eric about it, it's like, no, I feel like this is going to be a RAM storage problem. If I go down the implementing the algorithm exactly as written, I need to come up with the right algorithm. When Topaz wants to make brute force infeasible, he does so. Yeah, I believe that. Like, I 100% believe that. I have no problem believing that. What I want to do... If I look at these, we can calculate it. Oh, I don't have the terminal open. We could calculate it backwards. James, it is telling you things that don't matter that are causing you to go down the wrong path. Yes, it's a puzzle. I'm aware of that. Don't say anymore. I don't want hints. Like, don't, even if you think like you're being coy about it, I don't want that. I want to figure it out on my own. Because when I get this victory over Bad Cop, I want to earn it. So this is, no, you're good. You're good, man. You're totally good. I'm not upset with you or anything. I'm just letting you know, like, going forward, like, I don't want you to say anything that could possibly become a hint. Like, you're totally fine. Don't worry about that. Let's see. This is the number that would have split into that. So in order to get that number, it had to have been multiplied by 1024. On the bright side, Bad Cop is also spiraling. I feel like I should just like jump in there and be like, yo, like, what the hell's going on, man? Okay, so here's something interesting. When I divide this number by 1024, I get a decimal point. So this number is just unique. It's just a unique starting point. It's almost like this is an algorithm and we're seeding it with this number. Let me think about it like that. Would have been, oh wait, yeah, you're right. I'm stupid. You're stupid. No, you're not stupid. I am. Talking to myself. Use Rust. No. When I divide this new number, 125017, first of all, it ends in 7. So dividing it by 2024, doesn't work. Doesn't work. So this is just a unique number. This is just seeding this algorithm. Oh, I wish I knew more algorithm stuff. Oops. Yeah, so when we evolve this number, we get a 0 here. That's fine. We can calculate what will happen with that 0. But we just get like unique numbers. Like this number. This number is very unique. But it will eventually go down to single digits. Will, don't answer this, I'm talking out loud. Why are we, oh, it's the number of stones. Will every solution eventually yield a single digit? And when it yields a single digit, like 4, for instance, what can I do with that? Yeah, because in 1, 2, 3 steps, we get all down to single digits. But not every thing is going to work as beautifully as 4. Something, oh, well, that one worked really well. That one worked really well. Hold on. That got down to 8. When it gets down to single digits, we know a lot of stuff. So like when 6 here, we know that after this many iterations, we'll end up with all these numbers, and we can calculate how many iterations it'll take them to go down. So we have to keep track of a lot of data, though. I have to think about this. In order for what's going on in my head, we have to keep track of a lot of data, but I don't think we actually have to. I need to figure out how to throw some of this out. Because like once we get down to a single digit, we win. Because we can just pre-compute all of the evolutions and figure out what they turn into. But then I'm trying to figure out how to represent this data in a way that makes sense. Once we get down to a single digit, we can walk through the list of all the stuff it will do every iteration, and then we have a whole list of all these things that need to evolve, and we can just walk down their list of evolutions and evolve them, because we can handle one number at a time. I don't understand this. I don't know how to move forward. I don't want hints. No one say anything. I just don't know how to go from here to the answer. I feel like I'm missing some key element here. We know how they evolve. We don't even care about their order. We can just start with one number and work our way down the list and just keep evolving a single number because you just basically like tree out like this. We could work our way all the way to the end. If there's 75 evolutions, traverse 75 of the way down, get to an answer. We're making a tree structure. We're making a tree structure, and we're counting the length of the nodes at a certain level. And we're making a tree structure, and when we get to the bottom level, we just count the number of things at a certain level. Okay. But we need a way to like make it fast. Well, when the tree has a single number, we know how many nodes to add for it. I don't even know. I'm going to be honest. I don't know how we represent this data in Bash, what I'm picturing in my head. And that's kind of my biggest issue, is I have to figure out how to represent what I'm thinking of. I recommend a collection of bits, maybe some bytes. Yeah, dude, I think you're onto something, man. I think that's so true. Trying to think. I can come up with a recursive solution, but I think this is gonna have. I think it's gonna suffer from the same problem, because I think the math solution is what we want. But I can think of like the recursive one where we just, you know, go down and build the left leg of it first, and then walk up the tree, and then build the right, and walk up, and keep building all the nodes that need to be there. So if it was a tree thing, it would start from the left and kind of work its way over to the right. But we almost need like a checksum. Like once we have a layer of it, we need to just get the number of it and throw it out. Like we need to not carry so much of this data forward. It's not useful to us. Like I need a function, just talking out loud, if I evolve a number 75 times, how many stones get created from it? I need that function. And so I need to hash some of these things where it's like, oh, you want to evolve the number 4? Well, here's how it spins. Yeah, like this gets me to all single digits. I need to jump off of this idea. I think this idea is the winner, where I can get all of them back to single digits. But these are starting with the single digits, so I don't know what happens when you start with like weird numbers. Maybe those are just outliers, and we just have fast cache versions of some numbers that we've seen with some memo. Oh, thank you. Yeah, my bad. Sorry, I'm just going through the evolve program I wrote, and I'm just like, let's evolve the number 1. Let's evolve the number 2, and I can always get back down to single digits. So if I keep track of how these things evolve, but I have to figure out what I'm keeping track of. Because like even this, I can't just evolve the same number 75 times. It's just not going to work. Even the caching way, how does that cache not work? Or we memoize it. I feel like that should help so much more than it is. I know it's not, but like it should help more than it is. It's just that the data set's growing too big. There's just too many numbers to process. That's the problem. Yeah, once we start getting up here, I mean, that's just, yeah, we're growing way too big. Doubling every time, 75 iterations, we're at exponential growth. Like, this is just never going to work. Even if we've memorized all of the solutions, we need to reduce what we have. So we're basically going through paths that we've already figured out. We need to reduce them to just a numeric representation. But I don't know how to do that. Because these are nice, because they turn into single digits like all at the same time. But once you get to weird numbers like this one becomes a single digit before those become a single digit. So I'd have to keep track of that. They don't all become single digits at the same time. Is that one special? Wait a minute. Is it really just 7 that's special? Not that like that does anything for me, but like or 8. 8 was the one that was special. I'm going to write a new program. What we're going to do with this program is we're going to evolve until we hit a single digit. And we're going to count how long it took. No, right. It would help if I gave it some arguments, right? Yeah, so step 5. So I have to think about how to do this. Given the number 5, on iteration number 1, 2, 3, 4, 5, on the 5th iteration, given the number 5, you will get a single digit of 2, 4, 8, 2, 8, 8, 0. You'll get these. That's cool information to know. I have to figure out how to make that useful. What am I missing here? Like, what do I do with that information? I have it now. Why did I do this? No, because it's off by 1. And 8 was the one that was special, but it wasn't even that special. It just generated a 7 digit, like. I don't know what algorithm I even want to write here. I can't think of it. I might reach out to Bad Cop, see how she's doing, because I am getting one shot by this. If we have a single digit, like 8, we know that at the first one it's 1 stone, 1 stone, 2 stone, just 5 stone, 4 stone, whatever money. So like we can keep track of how many stones there are when we get to a certain thing. I wonder if just 16192 might just be special. Like I might just think of it as a special number because it's the one outlier. Yeah. If we just cache those numbers, then we know that let me start writing down some things. If we are at 8, then we know it'll go to 1 stone, 1 stone, 2 stone, 4 stone, and then however many stones this is, and then we know all the numbers of it at that location. So we can keep track of the stones, then we can keep track of a new pattern we need to run through. So we're going to write down all these by hand because that's stupid. Well, we shouldn't have to write them down by hand. We can do them in code. But so what I mean by this is like let's start with 2. Okay. Here's what we're going to do. Part 2. We have our cache. I don't know how to do this. Let's just make an array. So if we start with 0, then we just get to 1 right away. 1 pipe 1. If we start with the number 1, then we get to 2024, 2024, and 2024. So if we start with 1, then we get to 1 stone of 2024. No, we don't need to keep track of that. We get 1 stone, 2 stones, and then 4 stones with those numbers. So 1 stone, 2 stones, 4 stones of those numbers. I'm just coming up with a weird way to sort it, to store it, but just bear with me. Oh my god, this sucks. There's got to be such a better way to do this, but I don't care. right, so if we evolve 2, then we go 40, 48. Okay. Right, and then this one is just a duplicate of that one. Cool, which is 80, 96. No, let's just evolve at 5. 3 becomes 60, 72. Yeah, it doesn't double. That one becomes 80, 96. Okay, this is scuffed. Can't wait to see some of the solutions online for this. Okay, 11248. 11248. Okay. One, 1, 2, 4, 8. Wait, did I just do that one? Was that for 5? Yeah. One, 1, 2, 4, 8. Okay. One, 1, 2, 4, 8. There's gotta be a faster way to do this, but I don't care. One, 1, 2, 4, 8. And we need 9. 1, 1, 2, 4, 8. Then we need one more. The magic number. 16192. Did I get 8 wrong? 11247. You're right. Thank you. That would have been frustrating. I think it was 16192. 16192. Oh. Right. No, we're going to do one before that. Okay. Here's what we're going to do. We're going to grab it here. Okay, that's what we're going to do. We're going to grab it here. And that's 1124 for 8. For 8, it's 1124. We're going to grab these, and we're just going to cache these numbers, because these numbers are really easy to work with. So cache 32 equals 77, 26, and we already have 8. Okay, so 32. They all, actually, wait, they all just split, right? Yeah. So literally they just become 1, and it's 3, 2. Yeah. 1, 7, 7. 1, 2, 6. So that's the way that we do it. This is how many stones there are as we iterate through it. The amount of iterations is variable. We have this data now. What do we do with this data? We have to... I don't know what we do. We read the stones in. I guess let's just try and evolve the first stone. Alright, so what keyboard are you using? iMac, Mac, like, oh, it's wired in, I can't show you. Just whatever comes with the Mac Studio or iMac computer. We'll grab the first stone, and we'll try and evolve that stone, because we have a nice little memoization table here. So if the stone is cached, then we know how far it goes. I'm fried, dude. I don't know how to do this. Like, I don't... We have to get the stones that we're processing to these cache values. Once we're at the cache values, then we know how to jump forward with them really fast, but we don't even have the jump forward logic. Here's what we'll do. We'll make an evolve function. That takes the stone that you want to evolve, and we'll assert that it's in the cache. We'll just assume it's in the cache. I'm only going to try and evolve. We'll evolve like 5. We know it's in the cache. So if you evolve 5, this is what cache should now be set to. All right, let's do a read-r. First, or left-hand side, right-hand side, read in from cached. Now we need the read-r a values from right-hand side, and we need to read the stone count from left-hand side. So now that we know this, if we want to evolve 5 10 times, we know that in order to do that, we're going to go through the iteration of 1, then generates 1, then generates 2, then generates 4, then generates 5. Oh, crap. My headphones are dying. I don't know if this is going to work. I'm just going to assume that these don't work. Put on my headphones for this. At least they're wired in, they'll work. Okay. Okay, I'll say something. You tell me if you can hear me. Yeah, that's good. Yeah. Can I test if I just play her stream? Can I hear it? Okay. I can hear it. Yo, what's up, Bad Cop? Can you hear me?
Oh no, did you get
No,
it?
no. I am
Oh, okay.
spiraling. I have no idea how to do this.
I think I'm close, but I have a logic bug somewhere.
Oh, okay, cool. Then I won't distract you. I will let you figure it out.
I mean, I can give you some pointers if you want.
No, that's well. I don't know.
Your-
I got nothing.
You got nothing. What have
That's
you
not.
What have you tried?
I'm trying to figure out. It seems like every number you evolve eventually gets down to like a single digit number. So I'm kind of creating like a lookup table of all the single digit numbers. So like if you're trying to evolve the number 5, I know what path it will take. I know how many stones it will generate, and I know how long it'll take before it generates a whole bunch of single numbers that I then have cached. So I have like every possible single number cached. I know their exact path and how many stones they generate in the process. But I don't know how to do anything with that. And I have no idea if that's even close to the solution you're coming up with.
They all do they? I thought they would cycle.
That's what I thought too. But I have
No?
well, they maybe do if I use bigger numbers. I haven't really tested that. I just know if I simulated evolution on every single digit number, I get back to single digit numbers within the first 5 evolutions.
Interesting.
Yeah.
What I'm trying to do is I changed my solution to be recursive.
Okay, I thought about doing that too, and just walking down, like pick one number and always like calculate the left evolution, and then kind of walk your way back up. And I don't know if that's what you're talking about, but that's
Yeah. So
like a tree.
I'm trying to like, yeah, it's a tree. I go down the left side, and then on my way back up, I'm caching things like based on the item and the depth.
Yeah.
So I know like, right here it says if you see 2024 and you're at a depth of 2, then that's gonna end up being 6 numbers, which I don't think is right. So
Okay.
but that's the idea, is like I'm making a cache of like, okay, if you see this number at this depth, then it's gonna expand into this many numbers.
Right. Gotcha.
And so hopefully that will, I mean, it runs fast currently. It just gets the wrong answer.
Oh man. Oh, that's awesome. I wonder if I should have went down the tree route then. I mean, we still have time. I could go down it. Yeah, I'm just
Well, I mean, I'll be interested to see if yours also works.
well.
I had somebody in my chat be like, "Wait, where are you? Why is your cache like a composite key?" And I was like, "Yours isn't."
Yeah. Yeah. I know. I'm so worried about that. Like I'm like I know I'm caching too much, and I know I'm thinking about it too hard. Like I know the solution's simpler because I can't hold all this data on RAM, but I just cannot for the life of me come up with it. Oh man. All right. Well, I'll let you crank away. I will crank away as well. Feel free to bug me if you
I'm
have
getting
it.
close.
Oh my
I'm getting
god.
24, but it's supposed to be 22.
Oh my god. Well, good luck. I'm nervous now. Just thinking. I think I need to go the tree route. But I have this cache to like really speed things up. So if I'm like processing a single number and I've cached it, I can just shoot down that far. You're right. Thank you. I need to figure out an automatic way to do that. All right, how deep we want to go and what our current depth is. I'm winging things. All right. If we're here, we have the values cache. We can actually speed this process up. We can figure out how many stones are going to be generated, loop through all of them, increment the depth, and then local num stones equals 1. There's only 1 stone here. I don't even understand what I'm writing, I'm going to be honest. If the value's cache, then we read from that cache. We keep doing this until we hit the thing we want to go to. We can echo num stones, I guess. If we made it down here, then oh, well, it'll help if I spell the variable name correctly, huh? Okay. go. Depth. Cool. Unimplemented. Yeah, that seems right. Seems right. Well, that's not defined anywhere, so... Okay. I'm going to use some magic that I've learned from... Is it this? I need the magic that that bash cop uses. Whatever she does works good. Yeah, that's what I need to commit this to memory. Minus SD plus. Wait, no, that doesn't work. That's a Linuxism. That's not a portable solution. Instead, what I need to do is I just need to total them. I use that to total. So if we evolve 5 10 times, we get 36. So if we evolve 5 10 times, all right, why did I do that? Just evolve 5 10 times. We get 45, 32. Okay, so none of these even make sense. think we're on to something here. $67. Whereas if we evolve 5, 10 times, 45. Is this right? 56. No, 67. 67. Wait a minute. I think I'm off by 1 at one place, but that's okay. We don't have a cache result for this, so we have to do the work manually here. But that's okay. We have the logic to do the work manually. We might have a little off by 1 something going on here, but we're going to find out. This is wild. This is a crazy program. All right, we're going to evolve the number 5 10 times. Let's evolve the number 5 1 time. Evolve it 3 times. 4 times. I don't care about total. Let's do it 8 times. The answer is 22. The answer is 11. It's off by half. So it sounds like there's a +1 error thing going on here. Something's a little bit off here, but I think we're doing good. Oh. Let's be good. Why are we starting at depth 1? Yeah, we are starting at depth 0. Yep. And the first thing we do is we check if that's where we want to be. It's not. So now we have to actually go on and do some logic. $22. Was that right? Yeah, I think it was 22. So new evolve. No. No, 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 no.
Done.
Dude, are you serious? Oh my god, I literally just had a breakthrough and I think I might be very close to being done, but I'm not quite there.
My bug is gonna feel very familiar for you.
Okay.
I was missing a local.
No! No! Dude, really?
And then I put in the local in the wrong spot, and
No.
I was like, "Oh no, that wasn't it." And I was
Oh
like,
my god.
It's
You're
still-
lying.
Yeah, no, that took me like an hour.
Oh my god, that's incredible.
Actually, I don't know.
But you got it?
I just got it. Yeah.
Oh
it
my god.
runs pretty quick. Let me see. Let me time it.
Okay.
Less than a minute.
Wow, that's awesome. Oh my god, yeah, that's not bad at all.
Is it less than a minute? I don't know. Maybe it's a minute. Typical locals. 15 seconds.
Okay, that's not bad at all. Oh man, I'm literally at the point where I was just about to test this new thing. I mean, there's no... I'm gonna be honest, it probably won't work, but, you know, still.
For the record, okay. I'm not gonna read that out loud at the moment, but that's a cool feature. Yeah, Warp Talks, could you link your solution? I want to see how you did it with a different way. I'm gonna look at your stream real quick.
You're gonna look at mine? Okay, yeah. Mine is pretty wild. Why am I getting a syntax error now?
Have you kept going your same approach?
I have, yes. Wait, I think I just did something so stupid here. Yes, I did. Sorry, hold on. I'm deep in it. I don't know if you have my stream open, but I do have this like cache thing set where it's wild, but I keep track of how these grow. But I don't think I needed to do that. I think I could have just done the memorization thing that you did. It seems like that's way cleaner.
It was tricky to get right. There's a lot of fiddly places you can change the numbers and get very different answers.
Oh man. All right, hold on. Moment of truth. Moment of truth. Let's filter these out. And I tried to use your little paste technique, but apparently I don't think the paste thing is portable because my Mac complains about the syntax of it, like DS
I'm sorry,
plus.
are you manually populating the cache?
Listen, we don't need to talk about it. What are you talking about? Listen, I don't know what you want from me. What is the example input even supposed to give you?
Yeah, they don't tell you for this one, which is really weird.
Oh. Oh, yeah, they don't. It's just incredibly small. Oh, man. Oh, God. If mine takes this long on the example, I can't imagine how long it's going to take on the real input.
The real input's not that much bigger than the input. It's only like a few more numbers.
Okay.
So it's like, I don't know. It's like a factor of 5 slower at worst.
Yeah, but I don't think my cache logic is super sound. God, this sucks. Oh, aneurysms in the chat. He just, or they just said the fuck. God, I've been streaming for too long. They said the example correct answer in my chat. It's just a very large number, but.
Yeah, it is.
I don't even know if mine's gonna finish. I'm gonna be so real. So.
Are you dynamically filling in the cache too, or are you...
No, of course not.
Okay.
No, I should be, but I'm just not. So, yeah. I don't know. Is mine even still doing... I think it's mine still doing stuff, right? Oh, yeah. It's just outputting numbers. Oh, God.
You might have to do some of the summing in Bash. That's what I did. Like, I'm only piping like 5 numbers into paste.
Oh, okay. It's probably the amount of stones in the input, if I had to guess.
Yeah, it might just be like a lot of
Yeah.
I/O happening.
Yeah, I don't have a good way of, like... I need better debugging. I'm going to be honest, I don't know if I'm going to get this tonight. But congratulations. Oh my God, you are the true basher.
I mean, you beat first one or part 1.
That's true. And if we could run this program until the heat death of the universe, I think my solution would have worked.
Yeah. If we had infinite RAM and infinite CPU.
Yep. Yeah, I need to make my cache more dynamic. That's pretty much what I need here. Where's my debugging? All right, oh, that's why. I'm gonna try a tiny little bit longer, but I think I might just have to call it here because I don't even know what's going on.
It was a tricky one to even like. I spent so long while I was trying to convert it to recursive, just like wrapping my head around like how that was even gonna help.
Yeah.
Honestly, I think this just makes it worse.
Yeah, I completely understand that and feel the same way. Oh my God. Yeah, I think the cache has to be more dynamic, but I just don't know how to make it that way. I could do like debug, cache miss, stone. Yeah, I'm deep in the trenches. Oh wait, there's not many cache misses. It's probably all cache at that point then. I don't know.
Maybe just try doing some of the adding in Bash instead of doing so much I/O.
Yeah, you might be right. Like it might just be as simple as that. I could just do a total equals 0. Nope, I define it here. Where do I use total? I don't use it. Thank God. And then every time I echo num stones, I could just do. Oh yeah, you're right. This is so much easier. Total plus equal. Nope. plus equal num stones. I think I do that twice. Yeah, oh God, if it's just IO, that would be great. Yeah, we've been at this for a while. Oh my God, almost 4 hours.
I believe it's gonna work.
Well, it would help if I didn't hide standard out. I'm gonna need to not hide my answer when I get it. I don't even know what it's doing. What I'd have to do now is I'd have to bash minus exit and kind of just get an idea of where it's going slow. Or if it's even like getting in a loop or something, I actually have no idea. I don't know. I don't like how long this is taking. It seems like this is. Although you said no, you're taking a minute on the real input, right?
15 seconds.
Oh, okay. Yeah.
But it's like completely different approach.
Right, so. That's true. Yep. Yeah, it's definitely doing stuff. I think a lot of it is honestly probably reading the cache.
Oh yeah, someone in your chat has a good question. Does it still get the right answer for 25?
Does 25 blink is? Oh, that's a good question. That's a really good question. Let's not bash my exit. Five, 4, 1, 3, 6. Is that right? No, that's not right. It should be one higher than that. Now it's possible I'm off by 1. Totally possible. That's not right. Oh, wait. No. Yeah, no. I'm just not even getting the right answer. Whatever I'm doing is wrong here. Oh, that stinks. Is it? 55312 is what I'm supposed to get? Five, 4, 1, 3, 6. So just south of the right answer. So no, it doesn't. There's that. I don't even know. I'd have to rethink my solution. I'm doing something real slow or real dumb here. Yeah. Think I might have to give up. I don't know. Yeah. I can't think of any small fix I could implement tonight that would make this work.
Yeah, I have no idea if this even
works. Right. Yeah. I've taken such a weird approach. I was scratching my head at this. I'm like, I have no idea how to even pull out this data.
It makes sense to me that it would always converge back to like your premise makes sense.
Right. Like I could just try to identify loops, basically.
Yeah.
And they do seem to converge. I thought of
that and I was like, that sounds so hard. So
yeah.
I was like, that must not be the right way.
Yeah, it's tough. Like, yeah, I don't know.
I think that can work though.
I know there's something here. I can visualize it, but I can't quite express it in like data structures. This is one of those things where I'll probably get frustrated. I'll pull out Rust. I'll over-engineer the crap out of it, and then I'll come up with a solution that works because I can picture it in my head. I know what I want. Instead of having to construct the whole tree, I can just jump down X arbitrary number of levels, and I know how many stones that costs to do that. Like, there's something here. I just need more time to work through it. Oh man, oof. Well, what a good night. Oh my God, congratulations on your victory.
Thank you. Sounds like someone in my chat did it a different way than me, so I'm trying to see
Okay.
what they did.
Yeah, there's got to be some efficiency thing here. There's got to be some shortcuts to just cache this data, or I don't know. I keep thinking, like, I have a number. I know how many stones it takes to get to a single digit number, and then once I get there, we've converged in a loop, so I should be able to theoretically do it really quickly. I think my recursion is still too deep. But yeah, my number that I get is just south of what it should be when I do this. 54136, and it should be 55312. So I'm just missing like 1,000. So like plus equal 1,000 and we're done. That's like the solution, you tell me.
So how do you account for like the depth?
So let's see, at the bottom of my code where I actually call all this stuff. What's
Sorry,
up?
I'm just looking at someone from chat solution and it's so short.
Oh
I
God.
don't understand.
Yeah. I know these can be like
this?
these can be solved in like one-liners, which is crazy.
It's 18 lines of Python. I'm upset.
Oh, that's insane. That is insane. Yeah, what do? I loop over every stone and I run each stone through an evolve function. The evolve function takes the stone number, how deep we want to go, so 25, and there's a hidden third argument that I use for recursion. So where's my evolve function here, which is depth, and I start the depth at 0 if you don't initialize it. Then what do? If we are at the depth that we want to be, and we can only evolve one stone at a time, then we know the total is 1 stone, so we just short exit here. I don't know how the delay is on the stream, so hopefully it's not too hard to follow. Yeah, and then we check our cache, and I have this whole crazy caching language, and it's like, oh my God, I really over-engineered this. But it's cool. I know
I don't
that...
understand the Python solution at all, so this literally makes no sense to me.
That's insane. I'll have to look at that tonight. I'm so curious. Let me pop open your chat and grab it.
What?
Is it
What
Meepinator
is
with a
this?
gist?
Yeah.
Yeah. Oh, come on, man. This just hurts to look at. I can't look at this. Let's see. I'm gonna...
I don't understand why there's a loop to 25.
Maybe that's just supposed to be 75. Or not. Maybe it's not supposed to be. What do I know?
Meep, is this supposed to be 75? Please tell me. That should be okay. Thank God.
Yeah, so we range up 75 new stones. First stone.
It works for 10,000 plus.
I get it. I'm gonna kill myself. I can't say that. Sorry. In a video game. I don't know what the rules are.
Game. I don't. Wait. Explain it, because I don't get it.
Dude, oh my God. I will explain it. Give me a second. I have to just rethink my life. Oh my God.
Is this something that's easy to draw out?
Yes. Do you know Python? Do you know like default dict?
Yeah.
Okay, yeah, because we kind of have that in Bash. They just have...
we do.
Yeah, we have our declare dash capital A, and if you treat it like a number, it's 0. They're just keeping track of every time they've seen a stone. That's it. So at the first, like lines 3 and 4, for x and inputs.split, you just keep track of like, so if you have, your input is stone 5, 7, 8, You've seen stone 5 once, stone 7 once, and stone 8 once. Then you just do a loop 75 times. I know it's supposed to be 75, not 25. And you make a new stones default dictionary. And then you loop over the original stones. These are your inputs. And if it's 0, then you know it should evolve into stone 1. So you keep track of, oh, I've seen another stone of stone 1. If it's hold on, I'm losing it.
Oh, what?
Yeah, and then
That works?
if it's divisible by this, yeah, you keep track of your new stones, you keep track of your new stones. And then this is the key. You set stones equal to new stones because that is the level of the tree that you've gone through.
I'm
Yeah.
not happy.
And then you print the sum. Is that what you're supposed to do? Wait, are you supposed to sum all the stones? I thought you just show
It
how many
looks
times they
like-
show up. V for V in stones not value. I don't know this
Well,
much
this
Python.
is summing how many times they show up, right?
Oh, right. You're right. Yeah, you're just going through. Oh my God. Wait a minute. Hold on. If this is the
Yeah,
case,
this should be super easy to port.
yeah, like porting it to Bash would be such a joke. I just would have never come up with this algorithm on my own.
I'm gonna port it and see if it's faster than my solution.
Oh, okay. So we're gonna port it together, and we're gonna see who's faster. Got it.
Oh yeah, porting race.
You know it. Oh my God. I muted myself so she can't hear me. James, just so you're aware, I was not close. I know it may have seemed like it, but I can tell you just how my brain works. I would have never gotten this. I don't think in a million years I would have gotten this. Maybe if I took some time away, I would have done it, but like truly, I mean that. I don't think I would have gotten this. Like, that's just the truth. I appreciate you believing in me, but I really don't think I would have come up with this solution. Like, this was nowhere even close on my mind. I'm just going to try and port this exactly as is. You can't see it, but I'm just cribbing off the Python in the other window, which I grabbed from her chat. We just need to copy over the array, which I don't think is as easily done in Bash as you would like it to be. You have to pretty much do it manually. Do you lose Vim undo history every time you close it? Yeah. Yeah, because I save it and then I just close the buffer out. I don't want the undo history after I saved it. Oh, you know what? I'm mixing my syntax with their syntax. It's not going to work. It's wrong. Yeah, it looks like an integer overflow. Curious where that happens. Yeah, none of these are right. Which is interesting because I'm doing a plus equal on n, so the n value must be wrong at some part. Those look reasonable. They really just grow. Well, whatever they're growing by is wrong. It'd be so funny if the person in her chat just lied and the solution didn't work. I would laugh so hard. Looking through the solution, I understand how it works and I believe it should, but it'd be so funny if they just lied, wouldn't it? Like, that's actually hilarious. I think I would think that's very funny. Yeah, I don't think 84 showed up this many times.
Do you happen to know if numbers in Bash are 32-bit?
I'm running into the same issue. They should be 64-bit. They should be. I did say, I don't think this is true, but I said it'd be so funny if the person in your chat just lied and this just didn't work. Like, I would respect that so much.
No, I trust me.
Okay, all right, legit. I mean, like, and looking through the code, I get it. It should work, but I'm encountering that error too. The numbers are getting really, really big.
Yeah, they're wrapping around, aren't they?
Yeah, but I'm pretty sure we should be able to get 64. I've used 64-bit numbers in here before. Well, hold on.
Let me try
large.
with
Oh yeah, go on.
I'm gonna try with
Pipe out to like
5 iterations.
Oh yeah, I've been doing
No, 25 iterations. I still get the wrong answer.
Oh, I thought I was doing 25. I'm dumb.
Wait, why doesn't that work?
Yeah, when I do 25 iterations, I get a giant number.
Now I'm not getting any number. I'm so confused.
Oh, I think I got it. I think I got it. And I was doing something so stupid. So stupid. Listen, hey, you had a working solution of your own logic, so you win as far as I'm concerned.
Is yours, you got this working?
I got it working. I got the puzzle answer.
What am I doing wrong?
With the real input. I'll look at your stream in a second. I can tell you what I did. Because there's, copying an associative array from one to the other.
How did you, that's what I'm struggling
I looped it over.
I'm looping it over.
Okay, I have a theory.
Do I need to clear it out?
Mm-hmm.
Or how do I
Yes,
do
you do.
that? I can't figure out how to
Unset
do it.
and redeclare.
That's what I tried.
Make sure you unset, because I was unsetting new stones, but I wasn't unsetting stones. Yeah, so unset and declare, yep. And then make sure you do that with new stones if you have that thing
I
too.
have new stones as a local.
Oh, and you're doing it in a thing. Okay,
But
then
maybe if I declare in here, that doesn't work. If I declare it inside of a function, does it
I
not?
I didn't do any functions at all.
Yeah.
Yeah, I just completely skipped the functions.
Okay, what if I don't unset? Can I just empty it out somehow? Can I just say like stones equals that?
Not that I am aware of. For
Damn.
that's a great. I mean, I'll test locally, but I actually don't know the answer to that question off the top of my head. I'll just do it.
Bash clear associative array. Let's see. You can clear specific elements.
Apparently, I already made this. Oh my god. Oh yeah, what you just did worked. You're just setting it to open and close parent. That works for
Why am I still getting a
associative.
huge number?
Are you doing it to new stones as well when you're done with new? Oh no, right. Sorry, you're doing it in
So
a
local.
function. Yeah. Let me pull up your stream. Okay.
Did I, hold on. Did I read the indentation here right? Or is this? Yeah, this is still inside the loop.
I hate Python. I love Python. It's great, but I hate the indentation so much. It makes it so hard to find this exact situation. Yeah, so that is at the bottom of the
Yeah, so that should
range
be
loop.
inside the function. I still get big number.
Four stone and new stone. Stones. Okay, yeah, this looks right.
Wait, did you? No.
Regex.
This is N, right?
That
Yeah,
is.
I just copy pasted this from my other solution.
Yeah, that's gonna be N. Yeah.
Do you have to clear new stones after copying it? No, because it's a local.
You shouldn't have to. Yeah, it should be dropped out once the function's over. And you call the function, I assume, like 25 times or 75 times?
Yeah, it's
Yeah. And you do local stone, right? You're being good about your locals?
That's a great question. I mean, you can.
No,
do
you
that,
are.
right?
Yeah, you can. You can.
Is there another one that I'm not localing? I don't know.
I'm looking.
No, that's everything.
That is everything. Yeah. How is this
Just
not,
not.
I don't understand how this isn't working. Can you scroll down to where you call it? Yeah, you just okay. This is so basic. For stone in your array.
Why was the stuff loop nested? The stuff loop?
Yeah.
Is there another loop in here?
Oh, yeah. No. Yeah. No, that's a good point. All the way at the bottom. At the bottom of your code, look where they yeah. So for stone in array, and then you add that thing, that for I equals whatever I less than 25, that should be outside of that loop. You have a nested for loop there. If you look at the Python solution, it's not nested.
It's not nested? Oh.
I thought it was, but Python is very hard to read. It's not nested.
Oh. Is that the right answer?
I think it is.
For 25? Seems.
For 25, it's 55312.
553.
So 55,000.
I'm getting too big.
where do you... I don't know, I'm thinking.
Was this still... Did you lie about this? No. Okay, that is supposed to be N.
Yeah. It looks good to me. Stuff. What a good function name.
Well, I'll give up. I don't know. How fast does yours run for the...
I actually, now that you say that, I haven't actually tested it to get the right answer. Feels weird because it's not my own code. I'll go back and do this
yeah,
just
that's fair.
because I'm crazy about that. But let's see. For I in 1.25, let's change that to 75. Run, called it PyBash on the real input. Oh, I print a lot of stuff. Oh, wow, it's still finished. That gee, even with all that printing, it was super fast. Oh my god. All right, I'll time it. 2 seconds. Now, let's see if it's right.
I'm gonna get rid of this function.
That's the right answer.
I don't like this function.
That is the right answer. For my chat's own sake, yes, I will go through and I will figure out the solution I was trying to working on, and I will get it working. Maybe not in Bash, but definitely in Rust, because I have a tree structure in my mind. I'm going to make that work. But thank you, Meep. This is a way better solution. Oh my god, you did what I couldn't do.
What have I done? Line 12? Oh.
Oh, I had to do that same thing. I copied my old code over and had to get rid of all the locals.
Even getting rid of the... I don't understand. Is my left-right logic wrong? I don't think so.
It looks good to me.
I worked in my other code.
You unset stones, you declare dash cafe stones, you set it equal. Like, it all looks right.
Yeah, these all look sane. Meep, it doesn't work. You lied. I'm sorry.
But don't worry, Meep, it works for me. So thank you for giving me the secret
Yeah.
solution that only works for Dave.
How does it work for you? Why are there zeros left? When you printed left to right? Could there not be?
Were there like leading zeros or trailing zeros in the output? I didn't see any.
Yeah, it splits 2024 into 20 and 24.
No, that's a good question. Why is one of the left values... Oh, no, you printed number... Oh, no. Yeah, why is one of the left values zeros? That should never happen.
We're splitting 2 into 0 and 2? Oh, no. Oh, because it's not this. It's this. Oh. Yeah, that'll do it. That will do it. All right, there we go. So 25 go to 75. Oh my god, it's so much faster.
It's so much faster, isn't it?
P2 input. Oh wait, no, that's my original one.
It's like upsetting how
Input.
fast it is.
It's not instant. Let's see. Okay, it's about 5 times faster.
It's, oh man. I don't even know how to describe this. It made me so upset when I saw the solution. It makes perfect sense, and I don't know if I would have thought of it on my own, but like I've encountered this situation
I
so many times.
definitely wouldn't have.
I've encountered this situation where it's like you have to just reverse the data you're thinking about. It's like, oh, I have a stone, or like I have a stone I have to do work on. It's like, no. You have a count of how many times that stone appeared. You just have to like think about it differently. Like once you have an array that has all these duplicates, you got to start using like hash maps and frequency counts. That's the word I'm looking for. Oh man, it reminds me of like my computer science days, and I'm like, ugh, I can't believe I forgot this. It's so useful for these puzzles.
Well, that's exciting.
So, why was day 10 so much easier?
True. Can't wait for day 13. Can't wait to
No.
learn how to do matrix math in Bash.
I don't even know how to do it in other languages. I'm so scared.
You use a library.
Yeah, exactly. Yeah.
I mean, multiplying matrices is not too hard.
Yeah.
It's just how do you represent them?
That's the problem. The problem in Bash is always like I can picture it in my head. I don't know how to lay out the data in a way that makes sense.
Yeah.
Like, oh, I want a struct. It's like, nope. You get strings separated by sentinel characters. Oh, cool.
I don't know if it's actually going to involve matrix math, but the only spoiler I've seen is that there's linear algebra involved. So I can
Okay.
only assume we have matrices in our future.
Oh, I'm excited for this.
Hold on, we need to help this chatter. sboy3444 wants to know, how can I become really good at coding? I'm currently a beginner and I find it so hard to understand. I've been inconsistent for about 5 years on and off and still at a beginner stage. I have massive imposter syndrome. You got any advice?
Sure, I can give some advice. I will answer them the way I answer people on Instagram, because what I'll do is I'll reply directly to their comments with a video, and I'll say, "Listen, S boy. I mean, it's over. Skill issue. There's nothing you can do."
No, no, don't
but
listen, S-boy.
This is why I say I always start off the video with that, and then I go, "No, I'm just kidding. I'm kidding. It's okay. Everyone starts somewhere, and everyone's a beginner when they start." One of the things that's going to help you learn is consistency at whatever you're doing. So my advice is to pick a project or pick something you want to learn, and then set aside a time of the day where you do it. So either like a 20-minute block, or I always do this at 4 p.m. Pick a time, pick some sort of length of time, and make it so you do it. It's not going to be fun. You're not going to want to do it. You're going to have to do it with the same amount of discipline it would take to like do something like go to the gym or something, but this will be exercising your mind, not exercising your muscles. That's my honest to God advice, is literally section out part of your day so your brain knows, nope, now it's programming time. That will help you stay consistent. That's my advice.
Yeah, just to piggyback off that, very very similar advice. All you need to learn programming is a goal, and your goal should not be I want to learn how to program. Your goal should be like more specific and like have a clear finish line. Your goal should be like I want to make a website, or I want to make like a shitty little video game, or I want to don't make like a crazy video game. That's too hard. But like so have a clear finish line, and then just focus on taking the incremental steps to get there. Because it's so much easier to commit to stuff when you have some finish line in mind, and you're less likely to give up because you got stuck. And it's like having the goal of learning to code is so like nebulous and gigantic that you're just never going to finish it. That's my advice.
Oh yeah, I if I may piggyback off of that, that's incredible advice. I have this thing for my own life, but when it comes to like content creation, I have a list of goals and I separate them into active goals and passive goals. Active goals are things that I can actually do to make them happen. If I were to sit down today, I could knock out an active goal. Passive goal is something that happens automatically and I don't have any real direct control over it. So for instance, an active goal is like I want to make 2 videos. I could sit down and record videos and edit them, and I could be done in an hour. A passive goal is like, I want to hit 15,000 subscribers on YouTube. I can't make people subscribe. I can't come to your house and make you do that. But if I'm consistent with my active goals, my passive goals will just come. So I think wanting to learn to code is like saying, I want to get stronger. It's like, okay, that's a great goal, but you should set realistic goals now. Like, I want to go to the gym. I want to do these workouts. I keep using that as an example. You can use anything else as an example, but like, oh, you want to learn programming? That's great. Come up with very concrete things you can do and actual tasks you can tackle. And then make them manageable. Make them something you get done in a day. So feel good when you finish them. Like, don't rob yourself of that. Don't compare yourself to others. Be like, oh, I'm so far behind this person. It's like, yeah, but you're ahead of where you were before. So learn to celebrate your little victories, no matter how small they are.